Morning, math peeps. Welcome back to day 2 of implicit differentiation. Makes you sound so smart, I know. Okay, so let's start with this one. They give you the equation. I would like you guys on your own to show where the derivative is 0 or undefined. Okay, algebraically, show where the derivative is 0 or undefined. So, do your implicit differentiation and solve for dy dx, okay? Hit pause and do that on your own right now. Okay, so using implicit differentiation, 3y squared dy dx plus 14x equals 3x squared. Get the dy dx by itself, so I'm going to subtract 14x. So I have 3x squared minus 14x, and then divide by 3y squared, and we get dy dx equals 3x squared minus 14x over 3y squared. Okay, so there's my derivative. Let's reread the question. Algebraically, done, show where the derivative is 0 or undefined. Well, this derivative will be 0 if the numerator is 0, because 0 divided by any number is still 0. So the derivative will be 0 when 3x squared minus 14x is equal to 0. So solve that. Factor out an x, and you get 3x minus 14. Set each factor equal to 0, we get x equals 0, which is actually going to be a little off. And when we set the other one equal to 0, we get x equals 14/3. Okay, so what does that mean? 14/3 would be 4 2/3. And that's where we would have a derivative of 0. So at 4 2/3, 1, 2, 3, 4, and a little bit more right here, we're supposed to have a slope of 0. And we do. So that one makes sense when we look at the graph. This one, however, does this look like a slope of 0 right there? No. Well, that's because we haven't done the second part of the question. The second part is show where the derivative is undefined. Well, that's going to be when the denominator is 0. Well, that denominator will equal 0, obviously, when y is 0. And that's why this is actually undefined here. The derivative does not exist at a sharp point. See, it all comes together. All right, so part B, I don't know that we need to do this. If you want to, go ahead. We've done this many, many times. Now write the equation of the tangent at the point 8, 4. Go ahead and do that on your own. So if you chose to do that, part B, just plug in the 8 and the 4 to your derivative. And this is how you write that. I evaluated the derivative at 8, 4. Plugged in, all my x's are 8 and all my y's are 4. Simplified, and I got the slope to be 5/3. Put it all together, equation of a line, y minus y1 equals m times x minus x1. I don't think you really needed to do that because we've done that a few times. Okay, so main idea here, we were looking for where is the derivative 0 or undefined, and we got two answers. We had here's a slope of 0. Here was a slope that's undefined. Okay, so let's try something else. What do we got here? All right, very similar. This time, find all points where the tangents are vertical or horizontal. Well, if I want to know where there's a horizontal tangent, that means I want to know where is there a slope of 0. Okay, this is a huge one on the AP exam. This means I'm looking for where is the derivative 0, but I just won't use that notation. I'm going to use dy dx equals 0. Okay, vertical would be when the derivative is undefined. Okay, so vertical tangent is when the derivative is undefined, which basically means the denominator is 0. Horizontal tangent is when the derivative is 0, which is when the numerator is 0. Okay, and this is huge on the AP exam. You want to always write your justification first because you get a point for that on the AP exam. So write what you're going to do, then do it, okay? So now let's actually get that derivative. This is implicit differentiation because you have x's and y's mixed together. So here we go. The derivative, 2x equals, derivative of 4y is 4 dy dx. Derivative of y squared is negative 2y dy dx. The dy dx's are already on this one side on their own, so I can factor it out. I can also factor out a 2, but it doesn't really matter. What I really need to do is factor out the dy dx, and I'm left with 4 minus 2y. Get the dy dx by itself, divide on both sides, and I get dy dx is equal to 2x over 4 minus 2y. Okay, now I could factor out a 2 from this. I could simplify that, but I don't have to because this isn't my final answer. I have to do something with this. So rereading the question, find where we have vertical tangents and horizontal tangents. Okay, don't mix them up. Part A, the vertical tangent is when the denominator equals 0. Part B, horizontal tangent will be when the numerator is 0. Okay, solve that. Part A, we'd get y equals 2. And part B, we get x equals 0. Sometimes you can leave the answer like that, but it depends on the phrasing. Here, they want to know find the points. And that means we currently know that y is 2, but we still need the x coordinate. And on the other one, we know x is 0, but we need that y coordinate. So we have a little bit more work to do some of the time, not always. So for part A, to find the x coordinate that goes here, we're going to plug in that y is 2. Okay, well, if y is 2, we'd get 8 minus 4, we'd get 4. So x would equal either positive or negative 2. There's 2 answers. So that means my final answer to part A, I can have a 2 or a negative 2 here. So there's really 2 points. We have 2, 2, and negative 2, 2. Those are the 2 places where the tangent would be vertical. Part B, I know x is 0, I got to find the y. So if x is 0, solve for y. Okay, anytime you have a quadratic or higher, set it equal to 0 and factor. Factor out a y, and I'm left with 4 minus y. Set them both equal to 0, we get y equals 0 and y equals 4. So again, 2 answers. Okay, we have a 0 and a 4. So the answer to part B is going to be 0, 0 and 0, 4. Okay, because we're plugging in this 0 and 4. There's 2 answers that go right here. Okay, hopefully you're hanging in there. Hopefully you're doing well. Okay, the last thing for today's video, second derivative. First of all, you got to know this notation. This weird lingo means get the second derivative. Okay, so there's a little bit of a glitch with implicit differentiation when you do the second derivative. So hit pause and do the first derivative like normal. Okay, first step, I did my derivative like normal. Derivative of 3y squared was 6y dy dx. Get the dy dx by itself. Subtract 6x squared. Divide by the negative 6y. And we get that dy dx is equal to x squared over y. Okay, done for the first derivative. But now we got to do the second derivative. That means we're doing the derivative of this. Okay, no big deal. That will be a quotient rule. So here I go. The second derivative would be low, d high, 2x. I'm going to smush that together. Hold on. Okay, here was my low. D high is 2x. Minus high, d low. Well, the derivative of y is dy dx. Draw the line and square below, y squared. Okay, well, you might think that's the answer, but it won't be. And the reason is this derivative, this second derivative, has a derivative still in it. So all you do from here is replace this dy dx with what dy dx equals over here. So I'm going to take this guy and plug it in for the dy dx and then simplify. and then you'll be done. Okay, so go ahead and replace the dy dx with x squared over y. So I replaced the dy dx with x squared over y. I'm going to multiply these across and call that an x to the fourth over y. And you can see we're starting to get the same algebra over and over again. We can't leave a fraction within a fraction. So get rid of the problem. Get rid of this guy. So we're going to multiply everything by y, and a y. And I think hopefully we'll be done after that. I had to make a little space. Okay, so now this term will turn into a 2xy squared. This term, the y's cancel, and I just get an x to the fourth. And in the denominator, I have a y cubed. Okay, that would be my second derivative. Yes, I could factor out an x from the numerator, but you don't have to if it's not going to cancel. Okay, so we're done. All right, main idea on that one, let's go back to find the second derivative. You find the first derivative like normal, that was this. Then you do the derivative of this to get the second derivative. But when you do that, you're going to get another dy dx in that problem in your answer. So replace that dy dx with what you got as your first derivative and simplify. It's a little bit time consuming, but I don't think it's too difficult. All right, hopefully you guys are doing well. Good luck with your assignment. There you go. Bye.